Okay, number 1. We have LSAT scores and first-year scores. The admissions officer uses the regression line to predict first-year scores from LSAT scores. So this is LSAT, and this is first-year scores. Okay. The RMS error of the line is going to be, so the RMS error is 1 minus 0.6 squared, square rooted, times 10. Right? That is the RMS error formula. Okay. Letter A. One of the students is chosen at random. So we just pick somebody, and they landed. We have no idea. Oops. We don't know where they landed. Anywhere in here. Okay. Without knowing anything about his LSAT score, how would you guess the average? Or sorry, how would you guess that score? The average of the Y values. So we would pick 65 because that is the closest answer we have. Right? That is the middle of all of the Y values. Okay, B. Your RMS error would be so the RMS error is going to be the same as the original RMS error. Now somebody double check that in the back so I don't lead you astray. So 2b should be square root of 1 minus 0.6 squared times 10. It's 10? Oh, oops. Yeah, that's right. So if we pick this, how far would we expect that to be off? Well, it's the standard deviation of that number, which is 10. Okay? But if you are given the LSAT score, so now we know this point, oh my goodness, I can't grab it. This point, the X value is going to be told to us. So along with that point will be its X value. So let me link these together. Or no, not link, group. So now we know we know the X value of wherever that point lands. Okay? So if we have no idea where this person is, we are going to guess 65. That's the best we can do. But if we are told where on the x-axis it links, we can give a better guess. Where is that better guess? It's on the regression line, right? So if I tell you the LSAT score was 180, you're going to go over here to 180 and then up, and you'll choose this point. Is that going to be more accurate than the original? Yes, because originally we were just taking the average of all of those people. But once we know the appropriate X value, now instead of taking the SD like we did before, we can actually go up and down one RMS. And which is bigger? Is the SDY bigger or is the RMS error bigger? The SDY is always bigger. So if you know which X value to look at, then you can use the RMS error. If you don't know, then you just are stuck with the SD of Y. Okay, did that help? So that we did A and B, and then we redid A and B. Okay. 3. At a certain college, first-year GPAs average about 3 with an SD of 0.5. They are correlated about 0.6 with high school GPAs. Predict a person's first-year GPA using just the average. So a random person, what would their average GPA, or sorry, what would their first year predict using just the average. So person A, what would we expect their first year score to be? About 3. That's the best we can do. Person B predicts first year GPA by regression using the high school GPAs. Which person makes the smaller RMS error? Who's going to be more accurate? A random person who you just predict GPA, or somebody who predicts GPA using high school GPA. Yeah, using high school GPA. So this is high school and this is first year GPA. We would expect it to look like this. How highly correlated is it? A decent looking football, it's 0.6. So something like this. Person A is a prediction we use without looking at the X values. So how would we predict person A? We just take the Y bar, which is 3. Okay? Well, the next person, for person B, we know what X equals, some number, and then we are trying to calculate Y. So who's going to be more accurate? This guy is going to be more accurate. How much would we expect A to be off? We would expect A to be off by 0.5. How come? That's the SD of the Y values. How far would we expect B to be off? We would expect B to be off by square root of 1 minus 0.6 squared times 0.5. Right? Well, so this and this are equal, so this is the answer. How far off would we expect it? Who is closer and by how much? So we would expect it to be 80%. Does that make sense? 80% of the SD. That's how much more accurate the second person is.